Hello everyone, Mr. Fawcett here. We are back with another Algebra 1 lesson. Today we're going to focus again on a different type of word problem. So these are called distance, rate, and time word problems. So you should see the sheet in front of you. What I have done is I've copied a couple of these problems and I've put them on a Word document just so I have more space to draw some diagrams because it's harder for me to write smaller on the computer screen. But they're the same problems that you have on your sheet. So just pair up the numbers and we'll be good to go. We're going to start with number 1. So let's read it and let's talk a little bit about how to set this problem up. It says a passenger train left Washington and traveled towards Las Vegas at an average speed of 80 miles per hour. A cattle train left at the same time and traveled in the opposite direction with an average speed of 80 miles per hour. We're being asked to find out how long does a cattle train need to travel before the trains are 320 miles apart. Well, let's draw a little diagram here. So we have a train. You have to forgive my, looks more like a truck than a train, but we're going to call it a train for now. So we have one train going towards Las Vegas, and we have another train going in the opposite direction. So we have a train moving towards Las Vegas, and it is going at a speed of 80 miles per hour. Las Vegas. And it says we have a train going in the opposite direction and traveling also with the speed of 80 miles per hour. So this train is going this way, same speed, 80 miles per hour. And we're told we're being asked how long does a cattle train need to travel before the trains are 320 miles apart. So you can think of this as these trains move in opposite directions, the distance between them is getting larger and larger, right? So what we can do is we can say the distance that the blue train travels. So we'll say distance of blue plus the distance of the red that's going to equal total distance. And let me just explain why this works, right? So let's say that the red train has gone 10 miles. So I'm going to erase it for just a second to move it over. We'll just say it's gone 10 miles. That'll work for this. That'll work for this scenario. So the distance the red train has gone is 10 miles. And we'll say that the distance the blue train has gone is also 10 miles. If they're traveling at the same speed, they're going to travel the same distance for the same amount of time. So this distance is also 10 miles. Well, if we want to find the total distance between them, right, if we want to find this distance right here, well, we would add the total distance the blue train travels to the total distance the red train travels. Now, we should actually make sure that these are touching, right? Let's just do that. Okay, so the red plus the blue equals the total distance. Now we have to figure out, okay, how do we figure out how far the blue train travels? Well, we know it's traveling 80 miles per hour. So if it traveled for 1 hour, it would travel 80 miles per hour. If it traveled for 2 hours, it would travel 160 miles per hour, 80 times 2. If it was traveling for 3 hours, it would be going 240 miles, which is 80 times 3. So we can find our distance by multiplying the speed, the miles per hour, by the time. Now, we don't have a variable for time, so we just need to create one. I'm going to call it t, and I'm going to say, let t represent time traveled. And it's for both trains, because they left at the same time. Okay, so I have 80t for the blue, plus the speed of the red is also 80 miles per hour, times the number of hours, which is t, and that's going to be equal to the total distance, which we know is 320 miles, so 320. And now I have an equation I can solve. 80t plus 80t is 160t equals 320. Divide both sides by 160, and that's going to give us t is equal to 2. So the cattle train has been traveling for 2 hours by the time the trains are 320 miles apart. And it is good to write a sentence, so we'll say the cattle train travels for 2 hours for trains to be 320 miles apart. Okay, so this was a pretty basic problem. It was nice because the trains were traveling at the same speed and they left at the same time. We're now going to look at some problems that may be slightly different. Maybe the trains don't travel at the same speed, or maybe one leaves after the other. But again, we're following the same process as our other word problems. We're trying to take the information they give us, maybe set up a diagram or set up an equation using words, and then eventually turn that word equation into an algebraic equation. So let's clear this. Let's do another one. We're going to move on to number 3. And this one says, a container ship left Port 24 traveling north 9 hours before an aircraft carrier. So all that means is that it had a 9-hour head start on the aircraft carrier. The aircraft carrier traveled in the opposite direction, going 9 kilometers per hour faster than the container ship for 1 hour, after which the vessels were 97 kilometers apart. We need to find the container ship speed. Okay, this one's pretty wordy, and I don't like some lack of punctuation here. But essentially, you have one ship traveling north. So let's establish our port here. This is the port from which both ships start. You have one ship traveling north. It's a container ship. I don't know what container ships look like. So we will just have a shape and label it as a container ship. This ship has a 9-hour head start, which we'll come back to later. We have another ship, an aircraft carrier, going in the opposite direction. But it says that it's going 9 kilometers per hour faster than the container ship. And it says 1 hour after the aircraft carrier has started moving, the vessels were 97 kilometers apart. So we have a lot of information here. Let's start with our equation. We already know that if we add the distance, so if we add the distance that the container ship goes, let's make that a little longer here. Oops, still my eraser. Hate when that happens. So the distance of the container ship plus the distance of the aircraft carrier, right, that gives us our total distance. All right, so let's set up an equation. I'm going to do this over on the left and just hope I have enough space. So distance of the container ship plus the distance of the aircraft carrier equals the total distance apart. And well, we'll just say total distance apart. Okay, so it's set up similar to number 1. The problem is they give us different pieces of information. So the distance of the container ship. We know that it leaves 9 hours before the aircraft carrier. Okay, so it has a 9-hour head start. And we know that after 1 hour, so 1 hour after the aircraft carrier leaves, the vessels are 97 kilometers apart. So this means that the container ship is traveling for 10 hours total. So we're going to multiply 10 by whatever the speed is, because it's been traveling for 10 hours. I want us to understand the whole 10 hours part, though. So it has a 9-hour head start, and then 1 hour after the aircraft carrier leaves, the ships are 97 kilometers apart. So this total distance is 97, which means we can just, why don't we just add that in right now, equals 97. But we don't know the speed of the container ship, so we're going to save that for now. Do we know the time that the aircraft carrier travels? Well, we do. That's just 1, because it says 1 hour after the aircraft carrier leaves, the vessels are 97 kilometers apart. So we now need to come up with the speeds of the ships. Okay, we need to have the speeds so we can have a variable and then solve our equation. Well, we're trying to figure out the container ship speed, so why don't we let that be our variable? And let's just use S for speed. So let S represent container ship's speed. So I'm going to put S inside parentheses here. Remember, to find the distance that something travels, you multiply the time that it travels by the speed. So 10 is the time, S represents the speed. Now for the speed of the aircraft carrier, we have to go back up and look here at the problem again. We are told that the aircraft carrier traveled in the opposite direction and it goes 9 kilometers per hour faster than the container ship. So 9 kilometers faster is just S plus 9. So now we have an equation I can solve. And again, before you start to solve this equation, I would highly recommend that if you don't understand where any of the this equation came from, so where any of the parts came from, go back and re-listen to the explanation. If you still don't understand that after thinking about it and re-listening, write down that question so you can ask me about that at a later time. So I'm going to get 10S plus S, just distributing this 1, plus 9 is equal to 97. Combine my S's, so 11S plus 9 is equal to 97. Subtract 9 from both sides, I get 11S is equal to 88. And if I divide both sides by 11, I get S is equal to 8. And remember, we said S represented the container ship's speed. So 8 kilometers per hour is our answer. I think I forgot to circle the multiple choice answer for number 1, but that's okay. We came up with it. So same type of problem, but our variable was something different, right? Our variable in the first problem represented a time. The variable in this problem represented a speed. And that's why it's important to define your variable, to write down that little sentence about what your variable represents, what we did right here. Okay, I think we have time for one more. and we're going to do number 5. So it says Shreya made a trip to her friend's house and back. On the trip there, she drove 45 miles per hour, and on the return trip, she went 30 miles per hour. How long did the trip there take if the return trip took 3 hours? So we need to figure out how long did it take her to get to her friend's house. Well, this one's a little different than our previous problems. There's only one person here. There's only one vehicle traveling. And this one is called a round trip. So let's start by drawing a diagram. Let's draw a little car. If you guys thought my ships are bad, you're going to think my cars are even worse. So there's a car. We go to our friend's house. And then she takes the same car and she goes back home. Okay, so the trip there, she drives 45 miles per hour. We don't know how long it takes. On the trip back, she drives 30 miles per hour, and it takes her 3 hours. So we have to think about, what is our equation going to look like here? Well, if she travels to the house and then back, both of those trips should be the same distance, right? If you start at your house and you drive to your friend's house, maybe it's 10 miles away. When you drive back to your own house, that's also going to be 10 miles. So we can actually set up an equation here where we have trip, well, let's set it up like this actually. Distance to the friend's house should be equal to the distance back home. Now let's see if we can translate these words into some numbers and variables. So we've already said the distance, the way we find distance is multiply the speed by the amount of time that someone travels. So we don't have a time for the trip to her friend's house, but we do have a time and speed for the trip back. So we can start there. So the distance back, we would find that by multiplying 30 miles per hour times 3 hours. On the other side of our equation, we know that the speed is 45, but we are unsure of the time. So we got to come up with a variable for that. I'm going to call that t, and I'm going to say let t represent time it took Shreya to drive to her friend's house. Because that's what I'm trying to find. Now I have a pretty simple one variable equation to solve. I'm going to get 45t on my left-hand side equals 90. 30 times 3. So a little bit better, 9. Then I divide both sides by 45, and I get t is equal to 2. So it took her 2 hours to get to her friend's house. This equation looked different than the two previous ones, right? In the two previous ones, we had two distances being added together to come up with a total distance. But in this scenario, that equation wouldn't make sense, right? In this equation, we had a out and back trip. So the trip out to her friend's house should be the same distance as the trip back. So we could set those two distances equal to each other. Now you may, when you're attempting to solve these word problems, you may come up with an equation in words that you think is correct, but then you end up running into some trouble when you try to turn those words into numbers and variables. If you're having trouble doing that, it means your initial equation, your initial idea for what your equation should be, could have just been wrong. And you may need to evaluate it and say, hey, maybe I need a different equation, come up with a different one, and then see if that one you're able to turn into numbers and variables. So we're going to pause the video there. I think we're over 20 minutes. I would attempt the rest of the ones in this practice set. Again, a lot of them are different in the sense that they're asking you to solve for a different piece of the problem. But the process of thinking about the problem, maybe drawing a diagram if that's relevant, coming up with an equation in words first, and then translating it to numbers and variables, that process that we've been doing over the past few videos for solving word problems has been the same. The word problems have just looked a little different. So keep on practicing, write down questions you have, and I will look forward to seeing you next video.